Hello students, today we are going to start with a new lesson, that is circle. Before we start with circle, do you know what a circle means? Circle is a set of points which are equidistant from the center. So any point on the circle is equidistant from the center. Do you know what is a chord? Chord is a line segment which is touching the circle in any 2 points. Like for example over here AQ is the chord, QB is the chord. What is the diameter? Diameter is the longest chord. It passes through the center of the circle. So AB is the diameter. Then what is a tangent? Tangent is the line which touches the circle in 1 point. What is arc? Like for example you have this arc AB. Okay, arc is a segment, okay, which cuts the circle. Okay, a segment which is inside a circle is known as an arc. Okay, so you will be needing these all theorems when you solve the sums. About 6 to 8 marks sums are coming for your board exam. For that you need to learn all these theorems. When you find out some angles by using any of the theorems, you have to state the theorems on the right hand side. Left hand side is the statement, right hand side are the reasons. In that reason you have to state these theorems. So quickly we'll go through all these theorems. In the description box there is a link given. If you click the link, you have all these theorems whichever I am explained in the printed form. Please get the printout, hard copy, and write and learn this theorem. This will be helpful for you to understand the sums also, and also to write the theorems next to it when you are solving the sums in the board paper. So in the board, when you are solving the sums, when you find out any angles using these properties, you have to write the theorem, you have to state the theorem next to it. Alright, so now let's start with the first theorem. The first theorem says that the angle that an arc of a circle subtend at the center, see this is the arc AB, is double than that which subtend at any point on the remaining part of the circle. So angle at the center is twice the angle at the circumference. See, AOB is twice APB. Angle at the center is twice the angle at the circumference. Now just see, it starts with A and ends with B. So AOB, APB. See, starting and ending alphabet is the same. Did you see? So that's the way you can identify this theorem, by the starting and ending alphabet. So AB, AB, both the side AB. So one is at the center, one is at the circumference. Just see properly, looking at it only, it looks like angle AOB is greater than angle APB. So angle AOB is twice angle APB. Say supposing if you take angle APB as X. So then angle AOB will be 2X. That's how we have the first theorem. Angle at the center is twice the angle at the circumference, or the angle that an arc of a circle subtend at the center is double that which it subtend at any point on the remaining part of the circle. So to learn and write this theorem down. Okay, now theorem number 2. Angles in the same segment of a circle are equal. So now in this AB there is another angle which also is enclosed in the same segment or same arc. See, APB, AQB. See, starting ending is same now. Okay, but they are both on the circle. So if they are both on the circle, any number of angles which are on the circle, but they are subtend within the same arc are equal. Supposing there is another angle ARB, that ARB will also be equal to AQB and APB. Alright, because they are on the circle. Okay, so angle in the same segment of a circle are equal. So segment is AB. Like supposing if you join this AB, so that is the segment. Okay, so angles enclosed in the same segment are equal. APB is equal to AQB. So that is the next theorem, theorem number 2. Now theorem number 3. Angle enclosed in a semicircle is always right angle. Here this AB is the diameter. So both the end of the diameter should be covered. If any other chord is there and there is an angle there, you cannot say that is at 90. It has to be the diameter. How do you know it's the diameter? O is given at that point. Okay, between the 2 points A and B, there is O given. O is always the center of circle. So if O is given and if you see that this is the diameter, just check where an angle is there inside the diameter. You're going to get like this question in the exam. So AB is the diameter, starts with A, ends with B. Angle AQB is 90, APB is 90. So that is the second theorem. Third theorem. This is the fourth theorem now. Now opposite angles of a cyclic quadrilateral are supplementary. So now look at this angle D. Angle D plus angle B is equal to 180. Angle C plus angle A is equal to 180 because they are opposite angles. You know what is a quadrilateral? Quadrilateral is a four-sided figure, and cyclic quadrilateral means what? All the vertices of this quadrilateral lie on the circle. So what is cyclic quadrilateral? A quadrilateral in which all the vertices lie on the circle. So here we have angle D plus angle B is equal to 180, angle C plus angle A is 180. So the reason is opposite angles of a cyclic quadrilateral are supplementary. Now the fifth theorem. Exterior angle of a cyclic quadrilateral is equal to interior opposite angle. Now look at this angle CBE. That angle CBE is equal to angle CDA. Exterior angle of a cyclic quadrilateral is equal to interior opposite angles. Let's prove it. Although proving is not coming, but for the sake of understanding, I'll prove that this angle is equal to this angle. Now let's take this angle as we have 60. Okay, if this angle is 60, then this angle over here, linear pair, will be 120. Right? Linear pair means angles in a straight line. Adjacent angles, they sum up to 180. It's a straight line. So if this is 60, this is 120. Then using theorem 4, opposite angles of a cyclic quadrilateral are supplementary. That means angle B plus angle D is equal to 180, and angle B is 120. Substitute 120 plus angle B plus angle D is equal to 180. First of all, I'll write angle B plus angle D is equal to 180. Right? Opposite angles of a cyclic quadrilateral. Now instead of B, I'm going to put 120. So then what will be angle D? 180 minus 120, that is 60 degrees. So we get this as 60 degrees. In other words, angle CBE is equal to angle CDA. Got it? Now what you should do is draw the diagram, write down the theorem, understand it well, and then you go for the next 5 theorems. There are about 10 to 11 theorems which you have to learn, covering both the topics, circles as well as tangents. Now we start with theorem number 6. Now it involves tangents. Okay, that's another topic of circles, part 2. Okay, so the tangent at any point of a circle and the radius through the point are perpendicular to each other. So tangent is a line which touches the circle in one point. So PA is a tangent over here, PB is also a tangent. Now if you see, OA is the radius, OB is also the radius. The radius and tangent is perpendicular to each other. So angle OAP and angle OBP both are 90 degrees. Why? Radius and tangent. Okay, the tangent at any point of a circle and the radius, tangent and radius, are perpendicular to each other. That means both are 90. So when a sum comes, you have to just check whether when there is a tangent, see if the radius is touching. So if the radius is touching, then it has to be 90 degrees. Okay, angle OAP is equal to angle OBP is equal to 90. And then another theorem number 7, which is with the same figure, PA is equal to PB. In other words, tangent to the circle from external point are equal. So PA is equal to PB. From any point outside a circle, two tangents can be drawn and they are equal in length. PA is equal to PB. Now theorem number 8. Now, if two circles touch, the point of contact lies on a straight line joining the centers. If the two circles are touching, their centers joining them, if the two circles are touching externally, then the distance between the center is R1 plus R2. And if the two circles are touching externally, then the distance between the center AB will be R1 minus R2. Alright. So this is theorem number 8. Now theorem number 9. When two chords intersect internally or externally, the product of their segments are equal. Now see these two chords. Chords is what? A line which is touching the circle in two given points. So AB is a chord and CD is a chord. They are intersecting internally at point P. And these two chords, they are intersecting externally at point P. In this, the point P is outside. In this, the point P is inside. So if the two chords are intersecting internally or externally, products of their segments are equal. That means PA into PB is equal to PC into PD, or PA into PB is equal to PC into PD. See how I am giving the segments. PA, PC, alright. PA into PB is equal to PC into PD. Don't say PB into BA is equal to PD into DC. That will be wrong. So when you are writing the theorem, write the theorem properly and use the property properly. Otherwise, you will get wrong answer. So PB into PA is equal to PD into PC. PA into PB is equal to PC into PD. Both are same for both the circles. If the two chords intersect internally or externally, then the product of the length of the segment are equal. Now we'll do the 10th theorem. When a line segment intersect the circle and the tangent drawn, then the product of the segment is equal to the square of the tangent. That means PT square is equal to PB into PA. If a chord and a tangent, this is a chord and this is a tangent, intersect externally, they both are intersecting externally, then the product of the length of the chord or segments of the chord is equal to the square of the length of the tangent from the point of the contact to the point of intersection. That means PT square is equal to PA into PB, or the chords, the segment of the chord, the product of the segment of the chord is equal to the square of the tangents between them. Okay, when writing the theorem, you can write in short. Okay, the product of the chord, product of the segments of the chord is equal to the square of the tangent. PT square is equal to PB into PA. PT square is equal to PA into PB. Now the next theorem. Now to identify this theorem, there has to be a tangent and a chord. So when there is a tangent and a chord, then only this theorem is applied. So just see, whenever you are given a sum, then there is tangent and chord. Now supposing we are considering this chord AC. Okay, this is the tangent. So the angle between the tangent and this chord AC is angle CAP. Now just see which angle encloses AC. Just see in this circle which angle encloses AC. Which is the angle which encloses segment AC or arc AC? It is ABC. So we can say that angle ABC is equal to angle PAC. Now again, somewhere else, this is the tangent and AB is the chord. Now this AB chord encloses which angle on the circle? See, it is ACB. See the beginning and ending. Starts with A, ends with B. So ACB. ACB is the chord angle which encloses in the chord. So angle BAQ is equal to angle BCA. So the theorem is like this: angle between the tangent and chord is equal to angle in the alternate segment. Or the theorem what they have given. In short, you can write angle between the tangent and a chord is equal to angle in the alternate segment. If a line touches a circle and from the point of contact a chord is drawn, the angle between the tangent and the chord are respectively equal to angles in the corresponding alternate segment. So while solving the sum, when you get the answer, when a sum is given, then you have to write the reason. If you don't write the reason, they'll cut your marks. So write and learn these theorems nicely. In the description box, I have given a PDF file which has all these theorems nicely written down. You can take a hard copy, take a printout, okay, and just go through that nicely and possibly write and learn. Okay, so again, PQ is a tangent, AC is a chord. Which is the angle enclosed in AC? It is ABC. Angle PAC is equal to angle ABC. Then again, PQ is a chord, AB is the tangent. This AB is a chord and PQ is the tangent. And which is the angle enclosed in AB? Angle ACB. So angle BAQ is equal to angle ACB. Just see here, starting BCA, and chord is the BA. And which is the angle between the chord and the tangent? BAQ. So that's how BCA is equal to BAQ. You have to write this down and then practice. Then only you'll understand this better. This is one of the most difficult theorem. Okay, so you need a lot of written practice for you to understand this property. Okay, you have to see the tangent and you have to see the chord and which angle encloses the chord. So that finishes all the theorems of circles. Please go through it nicely, write and learn. And if you have understood these videos, do not forget to like, share and subscribe this video so that you will get more videos of this for Standard 10 ICSE. Till then, see you. Bye bye.